And so if you don't believe me, let's go like that.
Oh, yeah.
Oh, I see it. Glass is vibrating so fast.
Exactly. So what is that up at? What does it mean when it? What is the name that we give to how fast something's vibrating? It's
frequency.
No way.
Bingo.
Yeah.
Exactly.
Make it super low.
One really important thing. Nobody touches. Cool?
Yeah.
Okay, good.
It looks really good. I can't see it. No, it's in here.
Somebody would turn it
Hear
down.
that from our classroom.
Cool. That
was awesome.
So what's happening is I've got this hooked up to an amplifier that takes a very, very small signal from my computer. Very, I mean, like really small signal. And it amplifies it really big so that it can power the speakers. And actually, it's all hooked up through car battery back here.
Like electromagnetic forces.
Actually, an electromagnetic force is what actually causes these things to move. So we're going to talk about that in, actually, just about now. How are we doing on time?
We're good. I have a quarter till. My watch is a little fast.
No, but when do we have to say?
One.
Oh, we got lots of time. Wow, we went really fast. Okay, so questions real quick. Ooh. Yes, ma'am.
If you have that on and it's moving real fast, like super fast, if you actually look real close, like if you're real close to it, would you see it moving or would you not?
Yes, actually, did I already show the guitar string?
No.
I forgot all my cool videos. Okay, so a guitar. What do you do with the guitar string, right?
You make it vibrate.
So exactly, you make it vibrate. Now that's the right answer.
You pluck it.
So what ends up happening is if you were to go look up really close at it and have an extremely fast camera, this is somebody actually going normally just pink on a guitar string. But because it's being recorded in slow-mo, you actually get to see it vibrate up and down. And 3, 2, 1, 3. There you go. And so that's what a guitar string actually looks like in slow motion when you do it. And if we had a video camera up here that could record that fast, you would see the speaker and making those vibrations and waves in the air.
It's still moving.
Oh yeah. Yes.
I did that one since I take guitar lessons. We did that one.
Oh, you actually got a really high-speed camera? That is very cool. Yes, ma'am?
Everything that makes sound has vibration.
Yes. Okay, so the question was, does everything that makes sound vibrate? And the answer is yes, in some way. It's all energy. Remember how we started this out? Hey guys, come on. The way that we started this out was talking about a wave in the stadium. I'll get to it back to you in a second. And so what ended up happening is I put energy into a speaker, and it turns it into something that vibrates, and then that makes the air around it vibrate. And what happens with waves? Waves travel. Exactly. Have you ever, I mean, we've all seen waves in the ocean or in a lake or something, but they're always moving. They're not just sitting there going up and down. They move.
They move like
Exactly, and that's how the energy gets to us. Okay, so there's one last kind of wave. Well, actually, I think there's two more that we'll talk about. There's a wave that I don't have an experiment on. Oh, I'm sorry. Yes, ma'am.
When I was looking at it, fast, it looks really blurry.
Yeah, it does. It's just because our eyes aren't fast enough. Just like if we were to look at a guitar string plucked, it would look blurry to us. But if you had fast enough cameras, or if your eyes were really fast enough, you'd be able to see it slowly move. So there's another kind of wave that I think somebody had mentioned, which is, oh, thank you very much. Another kind of wave somebody had mentioned, which is light waves. Now, just like the wave in the stadium, that's a really slow wave, right? Yeah. And this one was a little bit faster because it started to look fuzzy and we couldn't see it. Well, it got even faster and the energy was going faster. So fast that we can't even imagine it would turn into light waves.
Ooh.
And the different colors that you actually see are, you know how we saw like the low frequency and the high frequency?
Yes.
Just like light, red is a very low frequency oscillation, and then blue is a very high frequency oscillation. And so everything about it has different ways that it's actually vibrating. Question?
So like if the It's the electromagnetic.
It's okay. I know what you're talking about.
The
If it,
electromagnetic. Gosh, something like that.
the electromagnetic waves.
Yeah, stop working in our eyes so we wouldn't see any color.
Let's see. Yeah, really what happens is the way that we see is the energy that is given off from the lights or bounced off of stuff. You know, the sun, if the sun wasn't there, if there's no light around us, things aren't just naturally giving off light. It actually reflects the light from the sun. And so those waves, exactly. So the waves hit it, and then they go to our eyes. And so for some reason, our eyes couldn't pick up those waves. Just like our ears. Well, how do our ears work? Well, they pick up the waves of air that are in the room. Just like our eyes, they pick up the waves of light that are around us. There's one other kind of wave that's out there that we haven't talked about that you can't see and you can't hear.
Air?
No, a little different than that. No, we're going to go straight into it. It's electromagnetic waves. Now, y'all have worked with magnets at all in your classes?
Yeah.
A little bit? A little bit? Well, have you ever played with a magnet at home, like on the refrigerator and stuff? Maybe trying to put two magnets together? Well, those are permanent magnets. Those are magnets that, no matter what you do to them, they really don't change, you know, if they push or if they pull to the North Pole or to the South Pole or any properties about it. But I can create a magnet just with a battery and a little bit of wire. And so the neat thing is what happens inside of something like this, I actually have a microphone on the front of here, and then there's a battery inside of it. And so what I do is the battery makes a little magnet in the antenna, and then my voice actually makes it go up, the energy inside of it go up and down and up and down and up and down. And so what happens? Do I need to be connected to another one of these with a cord? No, that wouldn't make any sense. Imagine if you were driving down the road and you were on your cell phone and you needed to call home and you had to connect a cord all the way back to your house.
And you're going to California.
Exactly, that wouldn't quite work. And so what we can do instead is use that idea that if I take electromagnetic energy and oscillate it, if I vibrate it up and down, and I have something else on the other end that has an antenna on it, this is a piece of equipment for my work, that can actually look at electromagnetic energy out in the air and display it on the screen. And so what I've got right here, if it comes up, right now these are the screens that are actually looking for energy out in the air. And so when I key up, as I make that whistling noise, it makes the energy go like that. But it makes it at such a higher frequency you can't hear it and you can't see it. And the really cool thing is that it goes through things. It goes through people, it goes through water, it goes through air, and, if I do this right,
It only connects to, Whoa!
Oh, wow.
That's loud. That is
it
loud.
can even go through doors. And so
That's
it goes through
loud.
everything. And so electromagnetic energy doesn't need air, it doesn't need water, it definitely doesn't need a string.
What if you just breathe on it?
How do you get that on your
Whoa!
So that's what's happening. So I make a little bit of energy.
What if you yell at it?
It won't look at, see that, you can see it's nice. If I don't do it, it looks like gobbledygook. So you can still see something. But the basic idea is that I'm making vibrations in the air with the magnet. So, let me go ahead and move this down. So, can anybody remember, so energy likes to travel in waves. Exactly. And how do you make waves? By
Vibration.
exactly. And what are all the things that you can vibrate? What? Air, water. Well, actually, to answer your question, when you vibrate air, that actually is sound. So that's how we hear it, because it's actually now when these speakers are going in and out, the air isn't moving all the way down there. It's just the energy that moves. So imagine there's like a little chunk of air right here. It's going like this back and forth. But just like the wave that we made in the room, when I went up and down, I didn't run to the other side of the room. I just transferred my energy to the person next to me. And so the very same thing happens in air when we